Hello, my dear students. Today we are going to discuss about learning in AI, and that is the second part of fifth module. You are already familiar with the term machine learning, right? Learning means acquiring something, actually acquiring knowledge and applying it in the future. So the ability of learning is the best thing that is being possessed by human beings, right? And our aim is that to make machines able to do what humans are doing in case of learning. That means to make machines able to acquire knowledge and apply it in the future. So suppose if you are going to design a system or program a system and programming for all the instances of the machine to respond, that is not that easy. So it is important to provide the system the ability to automatically learn and improve from the experience without being explicitly programmed. Each and every time we are going to the system and getting it programmed for each and every instance, that is practically impossible. So we have to make the machines learn things from the experience and apply it in the future, or make itself updated in the future. So what we do here is we develop computer programs that can access data and use it to learn for themselves. So all this can be achieved by effective knowledge acquisition. So acquired knowledge can be facts, theorems, it can be concepts, it can be rules, it can be functions, it can be in the form of formulas, it can be in the form of relationships, whatever. That is the acquired knowledge. And from where you can acquire knowledge? Knowledge can be received from different sources. There are different sources to get knowledge, and that sources can be the domain of interest. Suppose somebody is interested in IoT, that area of interest can provide you some information with whatever you want. It can be textbook, it can be papers, it can be journals, it can be databases, it can be internet, it can be reports, it can be previous works done by somebody else, it can be our own previous works. Many different sources of knowledge or data is available today. And to get details regarding the data that we have acquired, we can use metadata. That means metadata gives us the details about the data or knowledge that we are dealing with. So moving on to the concepts that we are going to discuss today. This area or this portion is completely theoretical. We do not have anything to implement with examples or something like that. So we are more into the descriptions, the meanings. What does that mean? What does the examples, practical examples likewise. So first we are going to deal with the different types of learning, different modes of learning, or different forms of learning that can be asked in any ways in the exams. So these are the different types of learning. Learning can be categorized with respect to the input and output, or with respect to the number of agents or the number of persons involved in that. So that is what more important that we are discussing today. And first we are going to discuss the types of learning according to the number of agents. So you have to write it down. All right. So don't write it down now. Okay. No need to make a confusion. When I am describing it one by one, you can point it out, and this presentation will be given to you, and you can get the details, diagrams from that. Okay. According to the input output, learning can be categorized into two: supervised learning and unsupervised learning. I think these two terms are clear to you or familiar with you when you are studying web data mining. And the next concept is according to the number of agents. According to the number of agents, we can divide learning into broadly into two categories, that is single agent learning and multi-agent learning. And what we are focusing on to is single agent learning. Okay, so single agent learning techniques are, there are different 9 different types of learning. So we will just some types are more similar to each other and some are entirely different. So we will see it one by one in detail. Okay. So in the left side, I've given the different types of learning, the terms, and first we are going to deal with rote learning. Rote learning is very familiar to us because as we are students, I'm also a student, right? I'm also studying every day. So the most important thing that we are doing regularly is learning by heart or learning by copy. We are just copying something into our memory We do not have a detailed idea about something and we are just by hearting it. So some answers or some area of our syllabus, if we do not know anything in detail about it, we do not know the concept in detail, we do not know what it is really, what we will do before going to examination hall, we will just try to read it. We will just try to by heart one or two lines. We will check whether there is any diagrams involved in that, and we will just mug it up or copy it out in your answer sheets. That's what happening in real life. So this type of learning, rote learning, is actually the basic type of learning. There is no reasoning, no application level concepts involved in it. It is just memorizing. That is learning by heart. So knowledge without any changes taken from the memory to the database. For example, chess. When we are playing chess, we are not formulating anything new there. We are just checking the rules in the database. We are just acting according to that rules. So we can save time because there is everything is already saved. We are just taking it from the database by using some search technique or some strategies, and we are playing it. So checkers playing program, chess program, everything is dependent on the board positions, and we are moving according to the rules that is being saved in the database. Nothing else is being discovered there. We are not even inventing something new. We are not discovering something else. So whatever happening is that we are just copying whatever is stored in the database. So no type of reasoning is happening. It is just learning by heart or copying. So that type of learning concept is called rote learning, rote, rote learning. And the second type of learning is learning from advices. Okay, this is also very much familiar with us. Not only human beings but also system can learn from advices. So we people are very much close to the advisors. We are getting advices every day. So you have to learn, you have to study, you don't waste time. So these are the instructions or advices that we are getting every day. So learning by being told by somebody else. This procedure is called learning from advices. We are not learning ourselves. We are learning by taking advices or by being told by somebody else. That type of learning is called learning from advices. This is actually a term which is coined by John McCarthy in 1958. So this is an early type of learning. So in our daily life also we are learning according to somebody's advices. So we can just compare with our daily life. So as we what we say as we start anything new, so it's quite common with the daily life that we take advice from our parents, from our friends, from our teachers. So for computers, what happens is the program is written by the programmers. So we programmers will give an advice or an instruction to the system, and the system will completely follow that instruction to perform a particular task. So that can be categorized into learning from advices. The next category is learning from instructions. Learning from instruction and learning from advice both are somewhat similar to each other. The difference is that learning from instruction is somewhat complex while compared to learning from taking advice. So here we are not getting everything programmed. We are just searching something also. That's why some more reasoning is being implemented here. So we are learning from instruction. In this case, the full concept is not programmed by the programmer. When we have a doubt, we are also interacting with them. So it includes a learning from teachers, learning by using books. So you are getting programmed or you are getting this, the advices, or you are getting instruction from your teachers, you are getting presentations from the teachers, notebooks, everything you are getting. And apart from the notes and ppt that you are referring, if you have a doubt, what will we do? We actually ask your teachers, right? Otherwise we will go to the internet and we'll search for some YouTube videos, or we'll search some sites. We will go for some publications. We will get any other type of sources from which we can get the answer for our doubts. So that's the only difference between the learning by advice and learning by instruction. Okay, fine. And the next type of learning is learning by induction. This type of learning can be explained with the example of kids. We have small kids in our home. or when we were small kids, how we are going to study something. When our parents tell that that's a car, we have seen a car once, we have just, that kid will observe the car, right? He will understand that it has four wheels, four doors, okay, and when enter into the car there are many different attributes, okay. He just observes what he is seeing, and when the next time he is seeing another car with another color, he can analyze that this is a car. How? This is being obtained from his observations, right? So, in our daily life, when we are getting some observations, when that kid is observing that a four-wheeler with some attributes can be categorized into car. So that kid have seen a red Maruti car first time. His parents said that this is a car. Next time he have seen another car. Parents said that, see, that's a car. See the color, it's blue. Okay, so the kid again observed it. And when he or she is seeing the car again and again, they form a pattern in their mind. So from the observation, they form a pattern that these vehicles with these properties, that's a pattern. And from that pattern, he is getting a hypothesis that the vehicles which is having this pattern can be categorized into a car. So after that, finally he comes to a conclusion, or he comes to a theory that the vehicle with four wheels, four doors, and interior that he has observed, he has generated, he formed a theory that it is a car. After that, whenever the kid see a car, he can identify, or he can analyze, or he can understand that that vehicle can be categorized into car. This is a small example from our day-to-day life. So when you are giving when you are trying to solve a problem, and when you are into a problem solving area, you are given with a color yellow, and it is mentioned that you have to get the output that the fruits with yellow color. So what you do is, you have a color yellow and you will search in your entire system, entire database of images, and you will get the fruits with the color yellow. And how you can identify a fruit? A fruit can be identified with some common properties, right? It will have a joining stem and a leaf sometimes. Okay, so a fruit can be identified than a vehicle. So that identification attributes will be there. According to that identification attribute, we are finding a conclusion that element or an image with so and so properties can be categorized into a fruit, and that's colored to be yellow. So I am getting the output as every yellow fruits. Okay. So, if we are telling the definition of this type of learning, it's nothing but we are trying to induce a general rule based on some observations. That is, the output is generated based on the inference done by the input. That means we have an observation, we have generated a pattern, we have formed a hypothesis, and we have a theory. And whenever we get another observation which is coming under the same pattern and hypothesis, we will understand that that theory can be true. This is the concept that we are using here. So you can best explain this with the example of a kid who is observing same type of thing regularly, and he is formulating a theory in his mind that this things are coming to this category. Okay. And the next category of learning is that learning by deduction or deductive learning. It's just opposite of inductive learning. In inductive learning, what did we do? We started from an observation, and frequently found observations, we have formed a pattern, then we have formed a hypothesis, and then we have concluded into a theory. Here it is just opposite of a induction. That means we have a theory with us, we have a hypothesis with us, we have different parameters, or we have different patterns with us, And according to this theory, hypothesis, and patterns, whenever a new observation comes to our mind, we can form a conclusion. So I will give you an example. Suppose Reena and Neetu. Reena and Neetu are cousins. Okay. So this relationship can be derived from what? The relationship of their parents. Okay. Suppose Reena's parent and Neetu's parent both are siblings. From that relationship, if you have got that relationship first, from that relationship you can derive that Neetu and Reena are cousins. How? It is from a theory. That means there is a theory that if two persons are siblings, then their children are cousins. Okay, so from that theory, we can derive, if we get the details of the parents of Reena and Neetu, we can derive into a conclusion that there are two relations there. Reena and Neetu's parents are siblings, and Reena and Neetu are cousins. So we can say that here it is given as x and y. We can say that x is a cousin of y if we have the knowledge of x and y's parents and the rules for cousin relationship. So we just need some rules. So this is already a theory. That means if two persons are siblings, then their kids are cousins. So from that theory, we have formed different patterns, which is making this theory true. We have different hypotheses as well. So from that, when we have a new observation that x and y are cousins or x and y's parents are siblings, we can form a new relationship that x and y are cousins. So this is something deductive, just opposite of inductive learning. We are starting from a theory, we have a hypothesis, we have different patterns, and whenever we are getting a new observation, we can classify that observation into a category according to the already existing theory. So it is actually what happens there is the system derives new facts from the existing information or knowledge. So the existing information is the details of Neetu and Reena's parents. So what is the new data that we have derived? Neetu and Reena are cousins. Okay, that is what is called deductive learning. And the next type of learning is learning from analogy. What does the term analogous means? Something similar, not actual example, something similar. Here it has been explained with the example of driving in your textbook. So I'll explain it with the example of driving. So if a person knows how to ride a cycle, he has a basic knowledge of applying brake, okay, increasing speed, okay, balancing the vehicle, right? He have a basic idea how to balance, right? That person can ride a bike or a scooter. How? Because they have the basic idea of balancing, they have the basic idea of applying brake and accelerator. So that basic idea is not the complete data that he is needed to ride a bike or scooter, but he can think analogously and learn that the data or the idea that I have from riding a cycle can be applied to ride a bike or scooter. And the same happens when I am going to ride a car or drive a car. നമ്മൾ ചില സിനിമകളിലൊക്കെ കേട്ടിട്ടുള്ള പോലെ സൈക്കിൾ ബാലൻസ് മതിയില്ലേ കാർ ഓടിക്കുക എന്ന് പറയണ പോലെ balance എന്നുള്ളൊരു idea we have, and we have an idea of applying brake, and we have an idea of uh, putting up the accelerator. That idea is not enough to drive a car, but we can think analogously. If we have a basic idea of driving, once if you have drive or once if you have ride on a bike or a scooter or a cycle on the road, you have a basic idea from which side you have to go, or how much speed you can take. That will help you to learn how to drive a car. That is the meaning that has been conveyed here. So in this type of learning from analogy, this is learning something through the use of similar known concepts, not the actual example. So this is a frequently used type of learning. So they given the example of learning by analogy may include the driving technique of vehicles. So one person who knows how to drive a car, he have a basic idea of how to drive a truck. The normal concept or the full idea of driving a truck is not similar to driving a car. But a person who drive a car has a clear idea of driving on a road, right? So that idea can be used to learn how to drive a truck. This procedure is throughout used in our lives. Okay, so wherever we are going through, we can include the knowledge that we already have in our own experience when we are trying something new. Moving on to the next type of learning, that is explanation based learning. It is very much similar to learning by instruction. So, what was learning by instruction? When we have to solve a problem and we are stuck somewhere, if we get the explanation or if we get the instruction how to progress, we can learn from that. So, that is it. Explanation based learning is similar to learning by instruction. That's why I'm not explaining it again. So the next is learning from examples. Learning from examples can be compared with learning from analogy. Okay, so this two can be asked for comparison. Compare learning from analogy and learning from examples. So what is the difference? The difference is that in learning from analogy, we are solving a problem with an idea in our mind that we have experienced before. In learning from examples, what the difference here is that we are going to do something, we do not have an idea about it, we do not have a previous idea about it, but our seniors do. And what will we do? We will get the idea from our seniors and implement in our system. The seniors' idea is an example for us. Our own experience can be analogy. Okay, that's the difference. So if I have done it before, a similar thing I have done before, and I have to apply it in the future, what I do is I have a similar experience before and I have learned from that analogy and I have put the idea that I already have into the new solution. And what comes the case of learning from examples? In the learning from examples, what means is that we personally do not have an idea about it, but we have examples with us. Okay, the best example is the project documentation that I have given to you, so you can relate it with more easily. When you are asked to document your project, you have not done it before. You have just documented your lab records, you have just gone through things like that, but you do not personally have a experience in documenting a project. What do? You will just ask your seniors. You do not have a given with a proper format. Okay, you are not given with a proper format, you have no examples given with you. So what will we do is you just take the examples from your seniors. You ask them to give their project documentation and you just take it granted. Okay, and what will we do? We will just edit it and we will submit it as ours. But learning from examples is different from that. Learning from examples means we are getting idea from the examples and we are using it into a study or into our solution. So for solving a newly designed problem, we use the corresponding old examples. That's the concept here. In case of analogy, this is not a real example for the solution that we are going to do, but it is something analogous, something similar. So that's the difference. Okay. The learning from examples can be best explained by the concept of decision trees that I will show you in later slides. Okay, so in later slides we have to elaborately explain the learning from example concept. So in that we will see the use of decision trees for learning from examples. Okay, and the next category of learning is learning from observations and discoveries. Okay, it's nothing but based on the existing data, a new form of knowledge is formed. So we have an existing data with us, we have some observations, we have some discoveries, and based on that we learn something. So we have observed that this particular thing is happening every day, and we have formulated a theory with respect to that, somewhat related to the learning by induction or something like that. So using this strategy, the learning system must either introduce a class description from the observing environment. ഒരു എൻവയോൺമെൻറ്റ് ഒബ്സർവ് ചെയ്യുന്നു, അതിൽ നിന്ന് ഞാൻ സ്വയം ഒരു 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 കൺക്ലൂഷൻ, അതിനെയാണ് ക്ലാസ് ഡിസ്ക്രിപ്ഷൻ എന്ന് പറയുന്നത്. കൺക്ലൂഷനെ ഞാൻ ഇൻഡ്യൂസ് ചെയ്യുന്നു, അല്ലെങ്കിൽ ഞാൻ എവാലുവേറ്റ് ചെയ്തതിൽ നിന്ന് ഞാൻ അപ്ഡേഷൻസ് നടത്തുന്നു. സോ ഇതൊരു അൺസൂപ്പർവൈസ്ഡ് ലേണിംഗ് ടെക്നിക്കാണ്. അൺസൂപ്പർവൈസ്ഡ് ലേണിംഗ് ടെക്നിക്ക് എന്ന് പറഞ്ഞാൽ നമുക്കറിയില്ല നമ്മുടെ കൺക്ലൂഷൻ എന്താണെന്ന്. അത് നമ്മൾ ഇനി കാണും. അപ്പോൾ കുറച്ചുകൂടി ക്ലിയർ ആവും കേട്ടോ. ലേണിംഗ് ഫ്രം ഒബ്സർവേഷൻസ് ആൻഡ് ഡിസ്കവറി എന്ന് പറയുന്നത് യു ക്യാൻ കാറ്റഗറൈസ് ഇൻ ടു വാട്ട് വി സേ. ഇപ്പം ഒരു എക്സാമ്പിൾ പറയുകയാണെങ്കിൽ ഒരു ബാങ്കിൻ്റെ കേസിൽ നമ്മളോട് പറയാം കുറച്ച് ആട്രിബ്യൂട്ട്സ് നമ്മൾ സേവ് ചെയ്ത് കൊടുക്കുന്നുണ്ട്. സോ ബാങ്ക് വെനെവർ വി ആർ അപ്ലൈയിങ് ഫോർ എ ലോൺ, how the bank will identify that we have a capability to pay back the loan. സോ അവിടെ നോക്കുന്നത് നമ്മുടെ സിബിൽ സ്കോർ നോക്കും, നമ്മുടെ ഇൻകം നോക്കും, സോ നമ്മുടെ ഏജ് നോക്കും, നമ്മുടെ ജോബ് നോക്കും. സോ ഇഫ് എ പേഴ്സൺ ഇസ് ഹാവിങ് എ പെർട്ടിക്കുലർ ഏജ് ലിമിറ്റ്, ഇപ്പം ഇത്ര ഏജിനിടയിൽ വരുന്ന ആൾ അല്ലെങ്കിൽ ഒരു സീനിയർ സിറ്റിസൺ ആയിട്ടുള്ള ആൾ, അപ്പം പ്രോബബിലിറ്റി ടു പേ ബാക്ക് ദ ലോൺ ആർക്കാണ് വരുന്നത് എന്ന് നോക്കും. ഇൻകം, ഒരു സീനിയർ സിറ്റിസൺ ആയിട്ടുള്ള ആൾ മന്ത്ലി ഇൻകം ലെസ് ദാൻ 5,000 ആണെങ്കിൽ ദ പേ ബാക്ക് കപ്പാസിറ്റി ക്യാൻ ബി ലോ ആണ്. അപ്പോൾ ഇതിനു മുമ്പുള്ള ഒബ്സർവേഷൻസ് ആ ബാങ്കിൻ്റെ കിടക്കുന്നുണ്ടാവും. അപ്പം ഇതിനു മുമ്പുള്ള ഒബ്സർവേഷൻസിൽ കിടക്കുന്ന രീതി അനുസരിച്ചിട്ട് ഈ ഒരു കാറ്റഗറിയിൽ വരുന്നവർ പേ ബാക്ക് എമൗണ്ട് കുറവാണെന്ന് ഐഡൻറ്റിഫൈ ചെയ്താൽ പുതിയൊരാൾ ഇതേ ഒബ്സർവേഷൻ വെച്ച് നമ്മൾ കമ്പയർ ചെയ്യുമ്പോൾ നമ്മൾ എന്ത് ചെയ്യും? ദിസ് ഈസ് അൺസൂപ്പർവൈസ്ഡ്. അതായത് ഇയാൾ ഏത് ക്ലാസ്സിൽ വരുന്നത് നമുക്കറിയില്ല, പക്ഷെ പ്രീവിയസ് നമ്മുടെ കയ്യിലുള്ള ഡീറ്റെയിൽസ് വെച്ചിട്ട് നമ്മളൊരു റിസൾട്ടിലേക്ക് വരികയാണ്. സോ സപ്പോസ് ഇൻ മൈ ഡേറ്റാബേസ് ഐ ഹാവ് എ ഇൻഫർമേഷൻ വിച്ച് ഇസ് പ്രൂവിങ് ദാറ്റ് a person within age limit of 25 to 40 having an income greater than 10,000, സിബിൽ സ്കോർ എന്താ പറയുക pretty good സിബിൽ സ്കോർ ഉള്ള ഒരാൾ has high degree or high probability to pay back the loan. അപ്പം അയാളെ നമ്മൾ കൊടുക്കുന്ന ഒരു ക്ലാസ് ഡിസ്ക്രിപ്ഷൻ കൊടുക്കും അയാൾക്ക്, സേഫ്, he is a safe person to pay back the loan. സീനിയർ സിറ്റിസൺ ആൻഡ് ഒരു ഇൻകം ലെസ് ദാൻ 5,000 per month വരുന്നു, അയാൾ സിബിൽ സ്കോർ കുറവാണ്. സോ അതുപോലുള്ള ആളുടെ പ്രോബബിലിറ്റി ഓഫ് പേയിങ് ബാക്ക് ദ ലോൺ ഇസ് റിസ്കി. അപ്പോൾ ഇങ്ങനെ നമ്മൾ ഓൾറെഡി ചെയ്തു വെച്ചിട്ടുണ്ടെങ്കിൽ പുതിയൊരാൾ വരുമ്പോൾ നമ്മുടെ കയ്യിലുള്ള ആട്രിബ്യൂട്ടിന് നമ്മൾ ഈ ഉള്ള ആട്രിബ്യൂട്ട്സ് വെച്ച് എന്ത് ചെയ്യും? കമ്പയർ ചെയ്യും. അപ്പോൾ പുതിയ ആൾ വന്നത് ഒരു 35 ഇയേഴ്സ് ഓൾഡ് ആയിട്ടുള്ള അല്ലെങ്കിൽ 30 ഇയർ ഓൾഡ് ആയിട്ടുള്ള ഒരാൾ, അയാളുടെ ഇൻകം ഒരു 15,000 ആണ്, സിബിൽ സ്കോർ വലിയ കുഴപ്പമില്ല. So we can categorize that person can come under safe category. സോ അതുകൊണ്ട് എൻ്റെ ഒബ്സർവേഷൻസിൽ നിന്ന് ഞാൻ ഫോം ചെയ്യുന്ന ഡിസ്കവറി, അതിൽ നിന്ന് ലേൺ ചെയ്യുക, ആ പ്രൊസീജിയറിനെയാണ് ലേണിംഗ് ഫ്രം ഒബ്സർവേഷൻസ് ആൻഡ് ഡിസ്കവറി എന്ന് പറയാം. ആൻഡ് ദ ലാസ്റ്റ് വൺ ഇസ് ക്ലസ്റ്ററിങ്, ലേണിംഗ് ബൈ ക്ലസ്റ്ററിങ്. സോ സിമിലർ ആയിട്ടുള്ള നമുക്കൊരു ഗ്രൂപ്പ് ഓഫ് ഡേറ്റ തന്നിരിക്കുകയാണ്, ഒരു കുറേ ഗ്രൂപ്പ് ഓഫ് ഡേറ്റ, സെയിം ബാങ്കിൻ്റെ എക്സാമ്പിൾ തന്നെ എടുക്കാം. ഗ്രൂപ്പ് ഓഫ് ഡേറ്റ നമുക്ക് തന്നിരിക്കുന്നു. ലോൺ, ഒരു വെഹിക്കിൾ ലോണിനെയാണ് നമ്മൾ സ്റ്റഡി ചെയ്യാൻ പോകുന്നതെങ്കിൽ വെഹിക്കിൾ ലോൺസ് എടുത്താൽ അതിനകത്ത് കാർ ലോൺ ഉണ്ടാവും, ബൈക്ക് ലോൺ ഉണ്ടാവും, ഒരുപാട് ലോൺസ് ഉണ്ടാവും. അപ്പോൾ ഈ വെഹിക്കിൾ ലോൺസിൻ്റെ ബേസിൽ ഞാൻ എനിക്ക് സിമിലാരിറ്റീസിൻ്റെ ബേസിൽ ഞാൻ ആളുകളെ കാറ്റഗറൈസ് ചെയ്യാണ്. സിമിലാരിറ്റീസിൻ്റെ ബേസിൽ എനിക്ക് ഏജിൻ്റെ സിമിലാരിറ്റിയുടെ ബേസിൽ കാറ്റഗറൈസ് ചെയ്യാം, അല്ലെങ്കിൽ അവർ വാങ്ങിയ വെഹിക്കിളിൻ്റെ ബേസിൽ കാറ്റഗറൈസ് ചെയ്യാം. അപ്പോൾ ഞാൻ വാങ്ങിയ വെഹിക്കിളിൻ്റെ ബേസിൽ കാറ്റഗറൈസ് ചെയ്യുകയാണെങ്കിൽ സപ്പോസ് ഐ ഹാവ് 2 ലോൺസ്, കാർ ലോൺ ആൻഡ് ബൈക്ക് ലോൺ, എനിക്ക് 2 ക്ലസ്റ്റർ കിട്ടും. ദ ഫസ്റ്റ് ക്ലസ്റ്റർ ഇസ് ബൈക്ക് ലോൺ ആൻഡ് സെക്കൻഡ് ക്ലസ്റ്റർ കാർ ലോൺ. ആ ക്ലസ്റ്ററിൽ നിന്നും എനിക്ക് അവരുടെ ഡീറ്റെയിൽസ് എടുക്കാൻ എളുപ്പമുണ്ടാവും. ഇപ്പോൾ സപ്പോസ് ബൈക്ക് ലോൺ എടുത്ത മിക്കവരും തന്നെ ഏജ് ലിമിറ്റ് ഇത്ര വരുന്നവരായിരിക്കും, കാർ ലോൺ എടുക്കുന്നത് ഏജ് ലിമിറ്റ് ഇത്ര വരും. അപ്പോൾ ഇനി അതിനകത്ത് തന്നെ എനിക്ക് മെഷർ ചെയ്യാം ഏത് ഏരിയയിലുള്ള ആളുകളാണ് കൂടുതൽ കാർ ലോൺ എടുത്തിരിക്കുന്നത്, അർബൻ ഏരിയ ആണോ റൂറൽ ഏരിയ ആണോ. സോ അത് നോക്കിയിട്ട് എൻ്റെ പ്രൊമോഷൻസ് അല്ലെങ്കിൽ ഡിസ്കൗണ്ട് റേറ്റുകൾ, ഇൻട്രസ്റ്റിലുള്ള വേരിയേഷൻസ് ഒക്കെ എനിക്ക് എന്ത് ചെയ്യാം? ഡെമോൺസ്ട്രേറ്റ് ചെയ്യാം. അങ്ങനെ സിമിലാരിറ്റീസിൻ്റെ ബേസിൽ ഞാൻ എൻ്റെ ഡേറ്റയെ കാറ്റഗറൈസ് ചെയ്യുന്നു, അല്ലെങ്കിൽ ഗ്രൂപ്പ് ചെയ്യുന്നു, ക്ലാസിഫൈ ചെയ്യുന്നു. ആ പ്രൊസീജിയറിനെയാണ് ക്ലസ്റ്ററിങ് എന്ന് പറയാം. ഓക്കെ, ദിസ് ഇസ് ലേണിംഗ് ബൈ clustering. So these are the 9 different categories of learning with respect to the number of agents. Okay, and the next type of classification of learning is according to the input and output. Okay, so if we are given with the input and if we are given with the output to which that data is to be classified, then that type of learning is called supervised learning. So here we will be given with the input and the output. So a bank data will be given and we will be having a 2 outputs, safe and risky. So I have to study the data that is being given to me, and I have to categorize that data into either safe category or risky category. That is the class labels. The class labels are already given to me. So in supervised learning, it learns from the labeled data. The data will be labeled as safe and risky. So whenever I am getting a new data, it is easy to categorize them. And The next type of learning is unsupervised learning, and here we will be given with the input label or input data, but we will not be given with the outputs or the output categories. I will be given with the bank data, but I won't be given with the output to which I have to categorize it. I have to just check the similarity without any prior conclusions, without any prejudice. What I have to do is I have to just check or compare the data with respect to different attributes, and I have to cluster the data. The similar data will come together into a group, and for that group I will label with the output. So the output will not be given like safe, risky. The output will not be given before the classification or grouping. So here the output and input will be given. Here the input is only given. That's the difference between supervised learning and unsupervised learning. So here is a broad classification of or a broad comparison of supervised and unsupervised learning techniques. I know that you have already been going through this, but even then I'm just explaining it. In case of supervised learning, I already told you that here the input and output variables will be given. In this case, only the input will be given, no output. Okay, and about the input data, what happens in the supervised learning is we are training the algorithm with respect to the labeled data. What is labeled data? If I am having a data of the bank, the each data entry will be having an extra column safe, extra column risky. I have a data like that with which is labeled as either safe or risky. So it is easy to classify them with respect to safe or risky class labels. Okay, so here the input data is according to the input data, that the input data is labeled data, and the algorithms are trained using that labeled data. Here no labels are given, only the data is given, and the algorithms are trained using the unlabeled data. Okay, now the next point, the algorithms used for learning is here it is SVM, support vector machine, neural network learning, regression, classification. Classification comes here, and here the clustering. In unsupervised, we use cluster algorithm, k-means, k-medoid, hierarchical clustering algorithms. Likewise, clustering is used here, and here it is classification. And the complexity. In supervised learning, it is simpler method of classification. No complex computations is coming here, but in unsupervised learning, we do not have a conclusion with us. So the comparison, the value computations are complex while compared with supervised learning. So unsupervised learning is computationally complex. And the use of data. In supervised learning model, it uses the training data to learn a link between the input and output. But here what happens is no output data is given with us, so we are not comparing it with the input and output. We are just checking the data comparison. We are just analyzing to which cluster it will go. And the next is accuracy rate. Here it is high accuracy because we are given with the class label, so no need to think more. We just have to classify it according to the class labels, so it is more trustworthy. But here we do not have a class label, and we are going to cluster it without any prior information, according to the similarities we are going to cluster. So here the accuracy may be sometimes lower. So when we are moving on to the real-time environment, this learning method is going on offline, and this method is more into real time. Because ഇതിന് എക്സാമ്പിൾ പറയുകയാണെങ്കിൽ ഒരു സൂപ്പർ മാർക്കറ്റിൽ ഓൾറെഡി വാങ്ങിക്കഴിഞ്ഞ ഡേറ്റയെ പഠിക്കുന്ന കൺസെപ്റ്റാണ് സൂപ്പർവൈസ്ഡ് ലേണിംഗ്. അതായത് നമ്മുടെ കയ്യിൽ വാങ്ങിക്കഴിഞ്ഞ ഡേറ്റയുണ്ട്, കഴിഞ്ഞു പോയ ആളുകളുടെ ഡേറ്റയുണ്ട്, അല്ലെങ്കിൽ ഒരു ബാങ്കിൽ ലോൺ എടുത്ത് തിരിച്ചടച്ചവരുടെ ഡേറ്റയുണ്ട്. ആ ഡേറ്റയിൽ നിന്ന് നമ്മൾ പഠിക്കുമ്പോൾ അത് ഓഫ്ലൈനാണ്, കാരണം ഓൾറെഡി ഡേറ്റ എല്ലാം എൻ്റെ കയ്യിൽ അവൈലബിളാണ്. ക്ലസ്റ്ററിങ് എന്ന് പറയുമ്പോൾ അല്ലെങ്കിൽ അൺസൂപ്പർവൈസ്ഡ് ലേണിംഗ് എന്ന് പറയുമ്പോൾ എല്ലാ ഡേറ്റയും എൻ്റെ കയ്യിലില്ല എന്ന് പറഞ്ഞാൽ അവർ ഏത് കാറ്റഗറിയിലാണ് വരുന്നത്, സേഫ് ആണോ റിസ്കി ആണോ എന്ന് എനിക്കറിയില്ല. അതായത് അടച്ചു കഴിഞ്ഞവരും വരാം, അടച്ചു കഴിയാത്തവരും വരാം എന്നുള്ളൊരു കൺസെപ്റ്റിൽ നിങ്ങൾ ചിന്തിക്കൂ. അങ്ങനെ ചിന്തിക്കുമ്പോൾ ഈ ലേണിംഗ് മെത്തേഡ് എന്ന് പറയുന്നത് റിയൽ ടൈമിലാണ് നടക്കുന്നത്. സോ അവർ തിരിച്ചടയ്ക്കോ അടയ്ക്കില്ലേ ഇതിൻ്റെ പ്രയർ ഇൻഫർമേഷൻസ് ഒന്നും നമുക്കറിയില്ല. ഇവരുടെ കുറേ ആട്രിബ്യൂട്ട്സ് വെച്ച് നമ്മൾ കമ്പയർ ചെയ്ത് അതിനെ നമ്മൾ എന്ത് ചെയ്യുന്നു, ഫോം ചെയ്യുന്നു. വേറൊരു എക്സാമ്പിൾ പറയുകയാണെങ്കിൽ ഒരു സൂപ്പർ മാർക്കറ്റിൻ്റെ കേസിൽ കഴിഞ്ഞു പോയ ഡേറ്റയെ ഞാൻ അനലൈസ് ചെയ്ത് ക്ലാസിഫൈ ചെയ്ത് പുതിയ റൂൾ ഉണ്ടാക്കാൻ എനിക്ക് സൂപ്പർവൈസ്ഡ് ലേണിംഗ് ഉപയോഗിക്കാം. ഇപ്പോൾ നടന്നുകൊണ്ടിരിക്കുന്ന പർച്ചേസുകൾ ഞാൻ എങ്ങനെ മോണിറ്റർ ചെയ്യും? ഒരാൾ ഇന്ന സാധനങ്ങൾ പർച്ചേസ് ചെയ്തു. സോ അയാൾ ഇന്ന സാധനം കൂടെ പർച്ചേസ് ചെയ്യാനുള്ള പ്രോബബിലിറ്റി ഞാൻ എങ്ങനെ മനസ്സിലാക്കും? അയാളുടെ ആട്രിബ്യൂട്ട്സ് വെച്ച് ഞാൻ അയാളെ ക്ലസ്റ്റർ ചെയ്യുക. ഇയാൾ ഇന്ന ഗ്രൂപ്പിൽപ്പെട്ട ആളാണ്, സോ ഇയാൾ ഇന്ന സാധനം വാങ്ങാനുള്ള സാധ്യത കൂടുതലാണ്. അപ്പോൾ താഴെ സ്ക്രോൾ ചെയ്യുമ്പം ആ സാധനം കൂടെ അയാൾക്ക് ഡിസ്പ്ലേ ചെയ്ത് കാണിക്കാം. നിങ്ങൾക്ക് ഇതുകൂടെ വാങ്ങാം, അല്ലെങ്കിൽ ഫ്രീക്വൻലി ബോട്ട് ടുഗെദർ എന്ന് പറഞ്ഞ് കാണിച്ചാൽ അയാൾ വാങ്ങാൻ സാധ്യതയുണ്ട്. സോ ഇത് റിയൽ ടൈമാണ്, ഇത് ഓഫ്ലൈൻ ആണ്. ഇവിടെ അടുത്ത് പറയുകയാണെങ്കിൽ നമ്പർ ഓഫ് ക്ലാസ്സസ്. ഇവിടെ ഞാൻ സേഫ്, റിസ്കി എന്നുള്ള 2 ക്ലാസ്സിലേക്കാണ് ഡിവൈഡ് ചെയ്യണമെങ്കിൽ നമ്പർ ഓഫ് ക്ലാസ്സസ് എത്രയാണെന്ന് നമുക്കറിയാം. ഇവിടെ നമുക്കറിയില്ല. സിമിലാരിറ്റിയുടെ ബേസിൽ എത്ര ക്ലസ്റ്ററുകൾ വേണമെങ്കിലും ഫോം ആവാം. ഇതിൻ്റെ ഒരു ഡ്രോബാക്ക് എന്ന് പറയുന്നത് ഒരുപാട് ഡേറ്റ വരുമ്പോൾ, ഹ്യൂജ് ഡേറ്റ റിയൽ ടൈമിൽ വരുമ്പോൾ ഇവിടെ ഒരു ഡിഫിക്കൽട്ടി വരും. ഇവിടെ നമുക്കൊരു പ്രിസൈസ് ഇൻഫർമേഷൻ ഒരു ഡേറ്റയെക്കുറിച്ച് ചോദിച്ചാൽ നമ്മുടെ കയ്യിൽ തരാനുണ്ടാവില്ല. അതാണ് ഇതിൻ്റെ ഡ്രോബാക്ക്. സിമിലാരിറ്റിയുടെ ബേസിൽ ഞാൻ അതിന് എന്ത് ചെയ്യാണ്, ക്ലസ്റ്റർ ചെയ്ത് തരാൻ പറഞ്ഞാൽ എനിക്ക് പറ്റും. പക്ഷേ അൺസൂപ്പർവൈസ്ഡ് ആയതുകൊണ്ട് തന്നെ, ലേബിൾസ് അറിയാത്തതുകൊണ്ട് തന്നെ ഒരു പ്രിസൈസ് ഡേറ്റ ചോദിച്ചാൽ തരാൻ ഇവിടെ ഇല്ല. This is a broad comparison between supervised and unsupervised learning. And that's all about the different classification of learning in AI. Okay, 2 types of classification. One is based on the input and output, that is supervised and unsupervised. One is based on the number of agents, single agent and multi-agent. And we are focusing on the single agent, and there were 9 different types of learning, which some types were similar to each other, some are different. Okay, that's it. Thank you.